All right, so this is our problem, and what I have written here are the givens, which were 20 meters. This distance was 20 meters. We were given the angle, and we were also given the total time taken from here to here, which was 4 seconds. Okay, so what I did to solve this problem is that I actually broke it down into two components, and I used the concept of parabolas to solve it. So remember what I said is that you always want to break things down into two components. So in this case, I basically only used the y component because I know a lot of things in the y direction. I know that at the very top, my velocity in the y component is going to be 0. So I can use this to my advantage. All right, so we're going to break this down into basically two parabolas. We're going to look at this side of the parabola, and then we're going to look at this side of the parabola. Okay, so what I did is I took time, and I arbitrarily said that the time to travel from here to here is a variable t. And so therefore, the time that it took to travel from here to here is the total amount of time minus t, which I have right here, 4 minus t. Okay, and then I said that this height was an arbitrary height that we'll call h. And so therefore, this height, which is the height of this parabola, is h minus 20, which we are given. Okay, so we basically have two variables now in the y component. All right, so in order to solve this, we need two equations. So I'm going to start over on this side. Okay, so I'm going to use this equation, which you have in your equation sheet. And I'm actually going to start at the top. So the way you can think about this is that you can pretend that you have a ball at the very top and you just dropped it. Okay? You dropped it. So now it's kind of the same thing in a parabola, except that you have an x component, right? So in this case, you didn't just drop it, but there's also a force pushing it in this direction, so it actually moved over here. But the time that it takes for it to travel this way in a parabola compared to, let's say if I just dropped something from the very top and it fell down, is the same. And you can think of it the same. So basically, we're going to take these variables, we're going to plug it into this equation. We know that the change in y is actually the height, and we know that the acceleration is gravity. So here I just, inputted the variables. So now I'm going to work on this side of the equation. I'm going to use the same equation that I used on the other side, and I'm going to use the same concept. I'm going to start at the very top. I'm going to say that I'm sorry, I'm kind of shaky. Okay, we're going to say that our velocity initially is 0, and our change in y is actually this, right? It's h minus 20. And our time is 4 minus t. So it's basically the same thing, a little bit different variables. So now I have two equations and I have two variables. So what I did here, in this whole crazy mess, is I basically substituted this h for this right here. Okay? You can see that there. This is basically just algebra, and I solved for the time. Okay, so you can double check my math, make sure that I did it correctly. So now I have time. I have this time, right? The time from here to here. And now I can solve for this time from here to here, which is what I would want to do because I have this component. I have this angle. Okay, so I redrew the last part of the parabola down here for you to show you that we have this angle. We want to basically determine the final velocity here. I didn't write that down, but this is the final velocity in the y component. Okay, and we're going to use the same exact concept, but we're going to use a different equation. So remember that v initial is at the very top of the parabola, and at the very top it's equal to 0, so we can cancel that out. And we can solve for v final. We know that our acceleration is gravity. We have t is equal to 3.17, so we basically just plugged in. and we solved for velocity. Now we have velocity in the y component, we have the angle, we need Vx. Because once we solve for Vx and we know the time, Vx is constant. We can just use this equation to solve. So what I did is I used the tangential of the angle is equal to opposite over adjacent. And I solved for my Vx, and I can't remember what the angle was, so you could just plug that in with the number that you have. And then it just simply reduces to, now that we know the velocity in the x component, remember that is always constant. This velocity does not change throughout the entire length of the projectile motion. So if we know the time it took to go from here to here, and we know the velocity in the x component, we can actually solve for the distance from here to here, which is what the question was asking, using this very simple, lovely equation. Okay, so I just plugged in, and you can check my math. If you have any questions, let me know.